Our next topic is going to be t-tests and one-way ANOVA. Now you should have seen both t-tests and one-way ANOVA in your introductory stats class. So most of this should be a review, so we don't go into it in great depth, but it should be a nice little review for these very commonly used methods. Okay, the data that we're going to use is drawn from Morin et al. This was a study that was looking at treatment of insomnia in older adults. So they just note at the beginning that up to a quarter of seniors report some sort of chronic insomnia, difficulty sleeping. So this data is going to involve 120 patients that are randomized to one of four conditions, and these are our four conditions. We have cognitive behavior therapy or CBT, we have medication, we have the combination of the two, or a placebo. Cognitive behavior therapy includes a number of components. So you have stimulus control, which is doing things like not doing anything but sleeping or sexual activity in your bedroom. So you don't eat in your bedroom, you don't watch TV in your bedroom. The idea is to create your bedroom and your bed as a place that you sleep. Sleep restriction it's very difficult, and it's the idea that if you might give a client and they say, well, I sleep 4 hours a night, and that's what I can get each night. And so what you have them do is you have them stay up, say till 2 o'clock in the morning, and then sleep the 4 hours till 6 in the morning. Maybe 6 is when they have to get up to go to work or something like that. So they're getting that 4 hours of continuous sleep from 2 to 6. And then you titrate them off of that a little bit so that they're sleeping longer, right? So because eventually we hope to get them up to 6, 7, 8 hours worth of sleep. The idea is to get them to have consistent, regular sleep that's uninterrupted. This is pretty hard, but works pretty well if you can get people to do it. Sleep hygiene is doing things like not drinking caffeine after, say, noon or after lunchtime, those kinds of things, avoiding your phone or iPad or whatever before bed. And then cognitive therapy is helping people deal with their negative thoughts that come up when they are having trouble sleeping. So if they wake up in the middle of the night and they're like, oh no, here I go again, I'm never going to get back to sleep, and sort of that rumination, anxiety that comes up, then cognitive therapy is geared toward that. Medication is Restoril. This is a hypnotic. It's very similar to something like Valium or Xanax. And then the third condition is the combination of those two. And then again, we have a placebo. So our main research question is how effective are the treatments relative to one another 3 months following the end of treatment. Okay, and we want to know how effective is CBT compared to the other treatments. Okay, and so here are our variables in the data set. You can see we have 120 observations. We've got a subject ID variable to identify each subject. We have the 4 treatment conditions, numbered 1 through 4. And then we have wake min, which is after they've gone to sleep, how many minutes a night are they awake per night, right? So how much time do they stay awake? So the first thing we're going to do is I'm going to pull us over to Stata for a few minutes, and we're going to explore this data. Okay, so the first thing we want to do is go ahead and load the data. So I'm going to clear out anything that I've got and load up this insomnia data. Okay, so now I've got that loaded up. Let's just do a codebook first, just to see, again, what we saw on those slides. Okay, so we've got our 3 variables here, just like we saw on this slide. So the first thing we're going to do is we're going to get some descriptive statistics. Okay, so I'm going to use the tab stat command. So that's a table of statistics. So we're going to do that first for the wake min variable. So we'll say tab stat wake min, and if you just do that, you're just going to get a mean. So what I'm going to say first is I want a mean, but I want to do it by condition. Okay. And then I'm just going to tell it specifically that I want the mean, because we're going to expand that here in a second. So if we do this, you see that we have our 4 conditions. We get the mean for each of them. You get the grand mean down here. Okay, so you can see that the placebo has the most number of minutes post-treatment that people are awake, right? So they fall asleep and they're up almost an hour after sleep at some time during the night, where these other ones are closer to a half an hour. Okay, so let's suppose we want some additional information. So again, we say wake min, we'll say by condition. This time I'm going to expand the stats, and we're going to take the mean, median, standard deviation, n, and the min and the max. So you run that, you get that full table now with each of these details. Okay. All right. So again, just to emphasize, based just on the mean and the median, for example, we really see that the 3 active treatments, whether they're combined or not, seem to be outperforming placebo. Okay, so let's look at this graphically. So I'm going to start with a box plot, and we're going to take that box plot, we're going to look at it over condition. Okay, so that's going to give us a box for each condition. Okay, and again, this is just a graphical representation of what we saw over here on the tables. In fact, these lines here in the middle are these medians. Okay, so again, we can visually see that the active treatments are having fewer minutes of wakefulness after sleep onset. An alternative to the box plot is sometimes called the violin plot. And so Stata doesn't have a violin plot built in, but you can add one that a user has written. So if you haven't done this before, you do ssc install vioplot. If you run that, it'll run. You'll see on my computer over here, it says that it's already, all the files already exist, and so it didn't do anything. But if you haven't done this yet, it'll add it there. Okay, so I'm going to comment that out, but again, you can add that to your installation when you want. So it's vioplot, and it has essentially the exact same syntax as the graph box. So we're going to say vioplot wake min, and we're going to do that over condition. I'm going to use the bird scheme again. And then I'm going to add a title here for the y-axis. Okay, so go ahead and run that. Okay, and you can see the violin plot. So what it has here is it has a box plot here in the middle. So it gets you a lot of the same kind of thing. But then what these things are, essentially the density or the distribution of the data across the range. And so it gives you a sense of, like, this one's a little more lumpy, right? It's kind of got like 2 pieces to it. Placebo's a little skewed. They're just more extreme values out here. Okay, so it's just a nice combination of the information you get from a box plot plus some information about the density. So you get to see a little bit more of the data. So it's nice to have in there. So from our descriptive data and the visualizations using the box and the violin plot, we can see that CBT seems to be a little bit better than placebo, or maybe even a lot better than placebo, for sure at 3 months, and then just a little bit better than the combination at 3 months. So what we might want to do then is to have a formal statistical test, and we can use the t-test to actually compare the means between the CBT and placebo condition and test whether they're different. So we're going to focus first only on the CBT and placebo condition, then we'll show, or comparison, excuse me, and then we'll show the other details. Okay, like any statistical test, you can state the null and alternative hypothesis. And I'd say that there are three ways to state the null hypothesis in a t-test. The first is that the means, remember this is the mean of the minutes awake after sleep onset, the means are equal to one another in the population. Another way of saying that is that the difference between the means is 0, right? So that there is no difference. Or the last idea is that the patients in the CBT and placebo conditions are sampled from the same population. So if that's true, whatever differences, right? If this is the population and both the CBT and placebo folks are drawn from that population, then any differences you see are simply going to be due to chance or sampling error, not due to any systematic differences between CBT and placebo. We have sort of the complementary versions of the alternative hypothesis, and this is again a two-tailed hypothesis, just like we did in regression. So the idea here is the alternative is that the two means for CBT and placebo are not equal to each other, so it's not stating whether CBT is better or worse than placebo, just that they're not equal to them. The second way is just to say that the difference between the two conditions is not equal to 0. And again, it's not saying whether it's positive or negative. And then the last idea here is the idea that the CBT and placebo conditions are sampled from different populations. So you might have, say, a CBT, so let's say that's CBT, and then this one's placebo, right? And so you can sample some from this group and this group, and part of the reason you might see some differences if the alternative is true is because they have different means here between them. Okay, they're different populations. All right, so in order to perform the t-test, we need to translate the outcome from the metric of minutes awake after onset, right? And we need to translate that into a t-value. So this is just like what we did when we did our t-test in regression, right? We don't have probability distributions for minutes awake after onset, so we need to standardize it, and we do that by putting it into a t-test, okay? So that is why we can't, right, do a statistical test with the outcome in its raw metric, because it's just, there's no way to do that, okay? So what we're going to do is we're going to follow our standard sort of formula, if you will, or structure for standardizing our values, right? So here we have the difference in the sample, okay, between condition 1 and condition 2. Then we have the difference in the population between condition 1 and condition 2. And then down here is the standard error for the difference between two means, okay? And the formula for the standard error is here, okay? So we have the variance for condition 1, the variance for condition 2, sample size for condition 1, sample size for condition 2. Take a square root and you get the standard error. Okay, so let's think through what each of these things mean. So this could be your CBT condition, and this could be placebo. Okay, and then this is the population value, right? So this is mu CBT, this is mu placebo. Okay, and then this would be the variance for CBT. This would be the variance for placebo. And their respective sample sizes. Okay? So remember step 0, right, from our null hypothesis test. If we remember that step 0 is assume that the null hypothesis is true, if we assume the null hypothesis is true, what's this difference here? And the answer here is that this is going to be 0. Okay? So under the assumption of the null hypothesis, the difference between the population means is 0. Okay? So this, essentially, we can simplify this by getting rid of that second part, because it's always going to be 0, assuming the null hypothesis is true. So to translate the outcome into a t-value, like I said here, we're going to take the difference between the means in our sample, divide by the standard error of the difference, right? Or of those two conditions. So now we'll go and I'll show you how to do this in Stata itself. Okay, the first thing we want to do is get the test of CBT versus placebo. So we're going to say CBT versus placebo. Okay, we're going to say t-test, wake min. Okay, I just want to glance at the data set and just for you to see that the CBT condition, when it's 1, right? When that value is 1, then it's the CBT condition. Okay, when the value is 2, it's the medication condition. When the value is 3, it's the combined condition. And when the value is 4, it's the placebo condition. So we're comparing condition 1. In this first one, where we're comparing CBT to placebo, we're comparing condition 1 to condition 4. So we want to use the if statement in the t-test to just limit it to that. So we say if condition equals 1 or condition equals 4. Okay. Then the last thing we need is we need to say by condition. So there's a number of ways in Stata to do a t-test. This I think is the simplest way for me anyway. But you can read the help command and look through it if you'd like to see the other ways to do it. Okay. So let me just read through this one more time. So this says do a t-test. Have your outcome variable be be wake min, right? Number of minutes awake after sleep onset. Limit our data to just these two conditions. So this is essentially by saying if condition equals 1 or condition equals 4, we're getting rid of conditions 2 and 3, which is the medication and the combination, when we do our t-test. If you don't limit it this way, it will give you an error because t-tests can only use 2 conditions at once. So if we go ahead and run that, we get our t-test. So you'll see a true sample t-test. Okay, gives you some descriptive statistics about each condition. So we see that there are 30 in each condition. We've got the mean for each condition, the standard error of the mean for each condition. Okay, and some other stuff here. So down here, though, is what we care about with the t-test, because remember, we're looking at the difference between the conditions. So if we subtract these two means here, we get a difference of negative 31.76667. And the standard error of that difference is 3.87. Okay? If we divide this 31 by the standard error, remember we're putting it into the metric of a t-value, then you get a negative 8.2009. Okay? The degrees of freedom for a t-test, in independent groups t-test or two-sample t-tests like this, are n minus 2. So we have 60 total people in the study, or in these two conditions. We subtract our 2, and so we get a degrees of freedom of 58. Okay, this tells you what the null hypothesis is. Okay, and then you actually get 3 values down here for p-values. This one here on the right and this one here on the left are for one-tailed tests. If you think the difference is negative, then that would be your one-tailed test. If you thought the difference was positive, that's your one-tailed test going this way. Then this one in the middle is your two-tailed test, which is the one we're evaluating here. Okay, this p-value says 0.0000, so that's just, again, telling you it's really small. It's not actually equal to 0, it's just smaller than this. And so it's, if I were to write this out, you'd say p less than, say, 0.001 or something like that, and that would give you your test. Okay? So key thing to remember here, make sure you limit the conditions to the ones you want. Okay? If you only have 2 conditions in your study, you don't need the if command. This is your difference in the raw metric. This divided by this, the mean difference divided by the standard error, gives you the t-value. You get your degrees of freedom, and then you have your p-value. Okay, we can do it again. This time let's look at the CBT versus combined condition. So it's going to be the same general setup. So wake min if condition equals 1. It's just now instead of condition equals 4, we're going to do 3 because the 3 was the combined condition. So if you go ahead and run this, then we get our test here. Okay, so we get a difference of negative 4.8 for the difference between the CBT and the combined condition. We get a standard error of 3.35. Okay, and this divided by this, 4.8 divided by 3.3, gives you a negative 1.43. We again have 58 degrees of freedom. And here we have a p-value of 0.1579. So in the case of the CBT versus placebo condition, p-value is quite small. We're going to reject the null hypothesis. Let's say we set alpha at 0.05. We're going to reject the null for sure there. And here, if alpha is 0.05, we retain the null. We fail to reject it here.